For the next problem, we know that a bat is flying with a velocity of 5 meters per second towards a flying insect with an unknown velocity. We know that the bat emits a chirp with a frequency of 40 kilohertz, and that the bat receives an echo of 40.4 kilohertz. We don't know if the flying insect is flying towards the bat or away from the bat. And we know that the velocity of sound is 340 meters per second. With this data, we need to know the velocity of the insect. For solving this problem, I am assuming that the flying insect is flying away from the bat. If you don't want to assume that the flying insect is flying away from the bat, you can put positive signs, but at the end the velocity will give you a negative value, which means that the flying insect is flying away from the bat. In order to solve this problem, I divided into two parts. In the first part, the bat is the source of sound, and the flying insect is the observer. So the perceived frequency is the frequency emitted by the bat times the velocity of the sound minus the velocity of the insect, because it's moving away from the source, over the velocity of the sound minus the velocity of the bat, because it's moving towards the observer. For the second part, now the bat is the observer and the flying insect is the source. So the frequency of the echo is the perceived frequency times the velocity of the sound plus the velocity of the bat, because the bat now is the observer and is moving towards the source of sound, over the velocity of the sound plus the velocity of the insect, because the source is moving away from the observer. If we combine these two equations and substitute the values that we know, we get this. And if we isolate B, velocity of the insect, we get that the velocity is 3.309 meters per second.